Hey guys, videos in this playlist are dedicated to the big level 7, 8 and 9, 4, 5 and 6 mark questions that we find towards the back of exam papers. So what I aim to do is show you how to first of all work out what a question is asking us to do, then how to plan our attack, and then carrying out the attack in hopefully easy to follow step-by-step solutions. So if you're finding these videos useful, don't forget to give us a cheeky thumbs up, support the channel by hitting subscribe, and if you find any questions that you think deserve a spot in this playlist, you can send them to me on Facebook or Twitter. Send me a cheeky little message, and if I think they belong here, I will do my best to put them in a video. Hey guys, in this video we're going to run through what I believe to be the hardest GCSE maths question I have ever seen. So this actually popped up on the 2017 Edexcel non-calculator paper, and I would say it really is quite tricky. So we've got this little shape here, this little arrowhead. It's actually a hexagon. It's made up of two congruent parallelograms. So two parallelograms are exactly the same. They're identical. And they are such that the length AB is equal to length BC, which is X centimetres. So already a little bit weird. We've got algebraic lengths. Good times. Now we've got point P on the line AF and point Q on the line CD, such that P to B is equal to B to Q is equal to 10 centimetres. Now we're told that angle ABC is 30 degrees, and we're asked to show that cos of angle PBQ is equal to 1 minus 2 minus root 3 over 200 times x squared. So this really is a monster of a question. We need knowledge of our standard trig values because it's on our non-calculator paper, and we need to use the cosine rule twice, which is quite weird because we don't really expect the cosine rule to turn up on a non-calculator paper. So let's have a look at how to sort this guy out then. Okay, so first of all then, what's our game plan? Well, we could make a triangle out of the points P, B and Q. That would be a non-right angle triangle. So we could indeed play with the cosine rule inside of that. But we want to show that cos of that top angle of triangle PBQ is equal to this rubbish down here. To be able to show what cos of an angle is using the cosine rule, we need to know all three lengths of the triangle. So we know that PB and BQ is going to be 10 centimetres. The question tells us that, but we don't know what the horizontal distance is from P to Q. So we need to think of a way that we could actually work out that distance P to Q. So let's zoom in on a diagram and see what we know. So the question tells us AB is equal to BC is X centimetres. So we're going to put that on our drawing first of all. So let's not worry about the cm, let's just call it X. Now we also know that angle ABC, so this whole angle up here is 30 degrees. So what we can actually do here is make a little triangle between points A, B and C. So if I draw in the base there, then that base is the length that we need. It's the length P to Q. So we can use the cosine rule now to work out this length. So let's first of all write down the cosine rule. So the cosine rule says a squared is equal to b squared plus c squared minus 2bc cos of a. So a nice little trick whenever you have to use the sine rule or the cosine rule is label your triangle to suit the formula. So let's call this little line down here A. Here's the guy that we're looking for. And then this angle up at point B, we're going to call that angle A. Now it doesn't matter which of the other two sides we call B and C, because they're both exactly the same anyway. Okay, so what we're going to want to do here then is plonk our lengths and our angle into the cosine rule. But before we do that, we need to know what cos of 30 is. So it's a non-calculator paper, so this comes down to our knowledge of standard trig values. So cos of 30 is root 3 over 2. So if you struggle with your trig values, I've got 2 videos showing you how to work them out when and if you need them. Okay, so next thing we're going to do then, as I said, is plonk our values into the cosine rule. So we're going to get a squared is equal to b squared is x squared plus c squared, that's another x squared. Now minus 2bc cos of 30. So b times c is x times x, so that's x squared. So we've got minus 2x squared times cos of 30, which is root 3 over 2. So that's given us an expression for what a squared is. It's not the neatest expression. So what we're going to do now is simplify that. So we're going to get a squared is equal to x squared add x squared is 2x squared. So we've got 2x squared minus 2x squared times root 3 over 2. Okay, that's simplified. Now what we could do, we can actually factorise this a little bit to make it again a little bit nicer. So we've got a common factor of 2x squared. So we can say that a squared is equal to 2x squared times 2x squared divided by 2x squared is 1. So we've got 1 minus 2x squared times root 3 over 2 divided by 2x squared leaves us with root 3 over 2. Okay, now what we can do inside of that bracket, we can turn that into a single fraction. So we can now say a squared is equal to 2x squared times, how do we turn 1 minus root 3 over 2 into a single fraction? Well, we can think of 1 as being 2 over 2. So we've got 2 over 2. The reason we can do that is because 2 divided by 2 is 1. So we've got 2 over 2 minus root 3 over 2. So then finally we've got a squared is 2x squared times 2 minus root 3 all over 2. And then actually we can simplify that one tiny bit more. This 2 on the bottom of the fraction will cancel out with the 2 behind the x squared. So we'll actually get a squared is equal to x squared times 2 minus root 3. Now up to there we should start feeling a little bit happy, because that's starting to look a little bit like the answer that we want to get. So I guess the last thing that we could do here is, well, we could say that a itself is the square root of all of that. So we could say it's x times the square root of 2 minus root 3. We don't really need that step though, because when we're about to use the cosine rule again in a second, we're going to square a, which is going to take us back to a squared. So this really is our first important result. So I'm going to clear this up, and then we'll have a look at tackling the rest of the question. Okay, so what I've done here, I've turned PBQ into a triangle and put on the lengths that we know. So we know PB and BQ are 10 centimetres long. Again, I'm not worrying about the centimetres. Keep things simple. So this base now of this triangle, the length PQ, we've just worked that out. But we're just going to think about it as A. And actually we're really only going to be worrying about a squared. So we've got that written down at the top here. So what we're trying to work out is here, well, it's now labelled angle A. So we're trying to show that cos of angle A is equal to this monstrosity down here. So how are we going to do that? Again, we're going to use the cosine rule, but this time we're going to use the cosine rule in its angle form. So if you're not overly happy with rearranging the cosine rule into its angle form, check out my video on the cosine rule. But basically we get cos of A is equal to B squared plus C squared minus A squared all over 2BC. So now it's a case of plonking our numbers in again. So it's not too bad. We know then that cos of A is equal to 10 squared is 100 plus another 10 squared is 200. So I'm going to write that down straight away as 200. So we got 200 minus A squared. So that's minus the thing we worked out above. So minus x squared times 2 minus root 3. And then that's all over 2BC. So 2 times 10 times 10. So that's all over 200. And now the really good news is we're pretty much there. So if we now just divide through by that 200, we get cos of A is equal to 1 minus 2 minus root 3 x squared all over 200, which is exactly what we wanted to show over here. So I know here I've got it as cos A. That's really just a little technique, as I said before, for when you're using the sine and cosine rule. Label your triangle, even if it's got labels on it, Don't worry about that. Put your own labels on to make it work with the cosine rule or the sine rule in the form that we are used to using. So instead of worrying about it here as cos PBQ, I just labelled that angle A, and then it's just cos A. So you're perfectly fine to do that. Okay, so we got our answer. We can put a cheeky little QED. Quite enough done. Hope you found this helpful, guys. Don't forget to subscribe, share with your friends, blah blah blah. Until next time, take care.